Thank you for watching Hack the File. I'm Michael Lopez, and on today's video, we're going to be doing the next video in the Python Networking 101 series. And this one is Essentials of Networking. Enjoy. All right, now we're back. So, Python Networking 101, we're on the Essentials of Networking chapter. So, I guess let's just dive right into this. Essentials of Networking. Networking is a process of connecting multiple computing devices to share resources, information, and services. As a network administrator, you'll be responsible for setting up, maintaining, troubleshooting networks. Let us dive into the essentials of networking to kickstart your journey towards becoming a network administrator. Network components. A computer network consists of several key components: nodes, individual devices connected to the network, such as computers, servers, routers, and switches. Communication media, physical or wireless connections that transmit data between nodes, including Ethernet cables, fiber optics, and Wi-Fi signals. Networking hardware, devices that facilitate network communications, such as routers, switches, access points. Networking software, applications and protocols that govern data transmission and network management. Network types. Networks can be classified based on their size, scope, and purpose. Personal Area Network, PAN, a small network that connects devices within a user's personal workspace, typically over Bluetooth or Wi-Fi. Local Area Network, a network that spans a limited area such as home, office, or campus. LANs typically use Ethernet or Wi-Fi to connect to devices. This is the most common. Wide Area Networks, a network that spans a large geographical area, often connected multiple LANs. The Internet is an example of a WAN. Virtual Private Networks, a secure encrypted network that extends over the public network, Internet, allowing remote users to access a private network as if they were physically connected. We should do a little series on VPNs. Network topology. Network topologies play a crucial role in determining the efficiency, reliability, and scalability of a network. Understanding these topologies allows network administrators to design optimized networks to meet specific requirements. Common network topologies include bus. Bus topology is a economical choice for small networks, as it requires less cable compared to other topologies. However, it is less reliable because if the central cable fails, the entire network is affected. Additionally, data collisions can occur due to shared communication mediums, reducing performance as the network grows. All this stuff you learn in your networking class, so I think it's kind of cool that they mix it with the Python. So that's what's cool about this book. Let's see. Star topology is widely used in modern networks as the central hub or switch acts as a single point of control, simplifying network management. It offers better reliability compared to bus topology, as the failure of one node does not impact the entire network. However, the central hub or switch can be a single point of failure, necessitating redundancy measures for critical networks. Ring topology offers predictable and consistent network performance, as each node is connected to exactly two other nodes, forming a closed loop. This topology minimizes data collision, but its performance can be affected by failure of a single node, requiring fault-tolerant mechanisms. Mesh topology is highly resilient, and multiple paths exist between nodes, ensuring data can be transmitted even if some connections fail. This redundancy increases network reliability, but comes at the cost of increased complexity and cable requirements expensive. Hybrid topology combines the advantages of multiple topologies to create a network tailored to specific needs. For instance, a network could use a star topology for connecting multiple departments, a mesh topology for connecting critical devices, ensuring high performance and fault tolerance. Network topologies significantly impact the design, performance, and reliability of a network. Administrators must consider these factors such as scalability, cost, complexity, and redundancy when selecting the optimal topology for a given network. This is probably the most hybrid is probably the most used, I would say. Network protocols. Network protocols define the rules and convention for communication within a network. Some essential network protocols include Internet Protocol. IP is a fundamental network protocol that assigns unique addresses to each device connected to a network, allowing them to communicate with one another. IP is responsible for routing data packets across the network, ensuring that the information is transmitted to its intended destination. The two primary versions of IP are IP4 and IP6, with IP6 gradually replacing IP4 due to its larger address space. Now, if you don't know what that means, that's a very cool topic. So, if you're getting new into networking, or you want to get into cybersecurity, or you want to get into the tech field, STEM field, whatever, Google this. Google the IP4 and IP6 replacing it, and then Google um, how many devices IP4 is set up to have. I mean, it's pretty interesting. Basically, we're gonna run out of space for devices on the internet with IP4. There's only a limited amount, and so we're trying to move in IP6, which gives us way more, right? So we probably won't have to worry for a long time, right? Um, Transmission Control Protocol (TCP) is another essential protocol that guarantees reliable, ordered, and error-checked data transmission between the devices. TCP establishes a connect between nodes, ensuring that data packets are delivered without loss or corruption. It also manages flow control and congestion of the network, contributing to overall stability and performance. TCP. User Datagram Protocol (UDP) is a connectionless transport protocol that offers fast data transmission with minimal error checking, making it suitable for applications where low latency is more important than data integrity, such as online gaming or live video streaming. Unlike TCP, UDP does not establish a connection, nor does it guarantee packet delivery. That's when we already know that when your whole damn thing crashes or you're lagging. Hypertext Transmission Protocol (HTTP) and its secure counterpart (HTTPS) facilitate communications between web browsers and servers. HTTP is the foundation of data communications on the World Wide Web, allowing users to access the internet with web pages. HTTPS adds a layer of security to HTTP through encryption, protecting data transmission between browser and server. File Transfer Protocol (FTP) is a standard protocol used for transferring files between devices on a network. FTP allows users to upload, download, and manage files on a remote server, enabling efficient file sharing and collaboration. Secure versions of FTP, it's not secure, such as FTPS and SFTP, incorporate encryption to protect sensitive data during transmission. This is usually hacked if it's not, if it's not closed, or if it's being used. Simple Mail Transfer Protocol (SMTP), an Internet Message Access Protocol (IMAP), and Internet Message Access Protocol (IMAP) are email protocols that govern the transmission and retrieval of email messages. SMTP is responsible for sending emails from a client to a server or between servers, while IMAP enables users to access and manage their emails on remote mail servers. Hold on, let me read that again. SMTP is responsible for sending emails from client to server. Okay. Or between servers, while IMAP enables users to access and manage their emails on remote servers. All right, I thought I read that wrong. The OSI model. Now this one, uh, it'd be awesome to understand it way better, but it's taking me a long time because there's so much crap. But to get this down is a necessity, I would say, right? The open source interconnection OSI. The Open Systems Interconnection OSI model is a vital conceptual framework that categorizes the functions of the network into 7 distinct layers. Gaining a thorough understanding of the OSI model is critical, see, and I agree, for network administrators, as it streamlines the process of troubleshooting network issues by enabling the isolation of problems in specific layers. Should we look at this? Well, I guess you can't. Application, presentation, session, transport, network, data link, and physical. Now we can't really read this unless I can zoom in on this, which I'm pretty sure I can. Uh, I can't. We'll read through this. How I remember this is this one looks like it's the first one, but it's not. It all starts. It was 1, 2, 3, 4, 5, 6, 7. So it goes this way. Because in reality, you're gonna start with the physical device, and then you're gonna work your way up to like the end, right? So this is how I remember at least the order, or at least, this is how I remember what's in it. So I start with the please do not throw sausage pizza away, and that's how I remember, right? I guess that's how you should remember it until you get it all locked down in your brain over and over again. But please stands for physical. Do is the data link. Not is a network. Throw is transport. Sausage is a session. Pizza is presentation. Away is application. Right, and that's going to be the order it goes in. So, all right. So the number one is the physical layer. That's why they start at number one, because it's going to start from your physical layer, right? So physical layer. This layer is now this is very important right here. This whole thing right here. Um, I'm gonna read it over and over again. I'm sure through this book. So by the time I get to the end of the book, I should have a better understanding of where to troubleshoot stuff. This layer is responsible for the transmission of raw bits over a physical medium, such as cables or radio waves. It also deals with the physical connections between devices, electrical signals, and synchronization. I worked in the field as a technician, electrical engineering technician, and this is what I primarily dealt with was the physical layer. Data link layer. The data link layer establishes and maintains reliable communications between adjacent nodes on a network. It is in charge of error detection and correction, as well as organizing data into frames for transmission. So remember, the nodes are different things on the network: computers, servers, right? Different nodes. Each node is a different thing. Is that what it said? So the data link layers establishes and maintains reliable communications between um, adjacent nodes on the network. So nodes that are next to each other or whatever. It is in charge of error detection and correction. So it's in charge of error detection and correction. Okay, so the network layer, layer 3. This layer handles routing and forwarding of data between different networks. It is responsible for determining the best path for data. packets based on factors like the shortest distance, lowest cost, and least congestion. Transport layer. In this network layer, there's a video that I watched in school that had the creation of the internet and why they created it, and it's a brilliant video. I can't find, I don't know where to find it, but if you find it, the creation of the internet, who created it and stuff, um, it's awesome, and it explains how these packets work and how they came up with the idea. It's basically military, right? So the transport layer. The transport layer provides reliable error check data transmission between nodes. It manages flow control and congestion management, ensuring that the data is transmitted and received in an orderly and efficient manner. Now, this is where the uh, SYN handshake is, I think. I don't know. Like I said, I'm not a network. This is one of my weaknesses, is the networking part, but we'll get through it. Session. The session layer manages and establishes. Oh wait, hold on. Session. The session layer manages and the establishment, maintenance, and termination of connections between nodes. It is responsible for coordinating communication sessions, controlling data exchange, and recovering from failures. Let me read that again. Session. The session layer manages the establishment, maintenance, and termination of connections between nodes. It is responsible for the coordination communication session, controlling data exchange, and recovering from failures. Presentation. This layer translates data between applications and network formats, handling tasks such as data compression, encryption, and character encoding. It ensures that data is presented in a format that both the sender and receiver can understand. Application. The application layer represents the interface between the user and the network. Hold up. The application layer represents the interface between the user and the network, providing high-level services such as email, web browsing, and transfers. Wait, hold up. The application layer represents the interface between the user and the network. Okay, that's what I read. Providing high-level services such as email, web browsing, and file transfer. It acts as a mediator between users and network processes, enabling seamless communication and resource sharing. The OSI model serves as a valuable tool for understanding and managing complex network systems, ultimately enhancing the overall performance and reliability of the network. So this basically goes over a brief description, but this is very important. I like how they put this in here. This is important. But when you take your networking class, you're going to go deeper in all these. IP addressing, if you take one. If not, get a networking book and then read that. Addresses serve as unique identifiers for each device within a network, allowing them to communicate and exchange data effectively. Two primary versions of IP addressing exist: the IP4 and the 32-bit addressing format consist of 4 decimal numbers separated by periods: 192, 168. Now, this is the most common. While widely used, the limited address space for IP4 has necessitated a gradual transition to IP4. See, this goes over basically why they're doing that. Then go deeper into Googling that and finding out. It's pretty interesting. The IP6 format, with its 120-bit address space, offers a significantly larger pool of addresses. The addresses are represented as 8 groups of 4 hexadecimal digits separated by colons, e.g., whatever. IP addresses can be assigned in two ways: statically or dynamically. Static IP addresses are manually assigned by network administrators, which you can do that. It's not hard. We're going to do it probably in this book. Whereas dynamic IP addresses are automatically assigned by a dynamic host configuration protocol, DHCP server. And we're probably not going to need this anymore. Well, I don't know. When you get the IP6, you're going to have so many IP addresses. You're still going to use this, but hold on, I'm thinking of another protocol. This server streamlines address management and ensures each device on the network receives a unique IP address. Furthermore, IP addresses are categorized as either public or private. Public IP addresses are globally unique and routable across the internet, while private IP addresses are reserved for use within your local network, enhancing security and enabling devices to communicate internally without direct exposure to the public internet. Subnetting. Subnetting is the process of dividing an IP network into smaller subnetworks or subnets. Subnetting improves network efficiency and security by limiting the broadcast domain and isolating network traffic. A subnet mask is used to determine the network portion of the IP address, with the remaining bits representing a host portion. So subnetting is just basically giving you little sub IP addresses in your network. Routing and switching. Routing and switching are core functions of a network. Switches operate at layer 2, the data link layer. Now let's go back over here. I want to see this. The data link layer establishes and maintains reliable communications between adjacent nodes on a network. It is in charge of error detection. So the data link layer is where your routers and switches are. Forwarding data frames based on the media access control is your MAC address, is your like physical address of your device. Switches maintain a MAC address table, learning the addresses of connected devices and intelligently forwarding data to the appropriate destination. Routers operate at layer 3, the network. This layer handles routing and forwarding of data between different networks. It is responsible for determining the best path of the data packets based on factors like shortest distance, lowest cost, and configuration. Forwarding data packets between networks based on their IP addresses, routing, maintaining table, determining the best path for data transmission based on factors such as number of hops, latency, and bandwidth. Switches are on layer 2. Look that back up. Yeah, okay, that makes sense because it's linked. So you're linking all of them together. Data link network is you're transmitting the data across the network between devices. That makes sense. So yeah, that would be the router. Network security. Network security is one of the prominent importance in today's interconnected world, as it safeguards sensitive data and upholds the integrity of computer networks. And this is the cybersecurity part if you're getting into that, right? A variety of network security measures have been developed to ensure the safety and privacy of information transmitted across the networks. Firewalls are essential components of network security, acting as a barrier between internal and external networks. They can be implemented as standalone devices or as software installed on a network device. Firewall filters incoming and outgoing traffic based on predefined rules, preventing unauthorized access and protecting the network from various cyber threats. Intrusion detection systems (IDS) and intrusion prevention systems (IPS) play a significant role in maintaining network security. These systems continuously monitor network traffic, detecting and analyzing suspicious activities. IDS focus on identifying potential threats and alerting administrators, while IPS actively blocks or mitigates malicious traffic in real time. Hold up. IDS focuses on identifying potential threats and alerting administrators. Yeah, Okay, that makes sense. While IPS actively blocks or mitigates malicious traffic in real time. Yeah, providing an extra layer of protection against cyber attacks. That's right. Virtual private networks, VPNs, are crucial for securing data transmission over public networks, such as the internet, by creating encrypted tunnels between network endpoints. VPNs ensure the confidentiality, and integrity of data, preventing eavesdropping, tampering, and unauthorized actions. Access control is another key aspect of security, network security, as it limits network access to authorized users and devices. This can be achieved through various methods, including the use of authentication protocols, role based access controls, and network segmentation. By implementing access controls measures, network administrators can minimize the risk of unauthorized access and ensure that only trusted users and devices can access sensitive data. Network monitoring and troubleshooting. Network administrators must monitor network performance and troubleshoot issues as they arise. Common network monitoring and troubleshooting tools include ping, test the network connectivity between devices by sending ICMP, which is your oh, okay, we haven't got over that. I thought that was the mail one. That doesn't make no sense. Echo request packets and measuring response times. Trace route the path data maps the path the data takes between two nodes, identifying intermediate devices and potential bottlenecks. Wireshark captures and analyzes network packets, providing detailed insights into the network traffic. Network analyzers and monitoring software collects and displays real-time networks performance metrics, helping administrators identify issues and optimize network performance. With this foundation, you can begin to explore the practical applications of networking using Python and build the skills required to become a successful network administrator. To me, knowing this foundation is itself an achievement and a starting point to career of networking professionals. So, do we want to do the summary? Do my own summary. So basically, you have two things going on here. You're either in some kind of IT classes in college or cybersecurity classes where you're taking networking 101 that's going to go over all this stuff in more detail. You're most likely going to be what networking book did I have in school? I can't remember if it was the Networking Plus they had us working from, but anyways, you're gonna take a class in this, and it's gonna go into detail about it, or you're not, right? And you're just learning all this stuff as a autodidact or whatever they call it. So basically, you're teaching yourself, which is fine. I mean, that's what my channel is about. It's about, I'm a firm believer in learning how to learn. And when you in some of these like colleges in these degrees are so new, anyways. All they're doing is, networking is not new. Okay, so you're going to learn the ins and outs of that perfectly, right? But other concepts in cybersecurity and all that, and whatever, are so new that they're going to be referring from books anyways. So from having you go from start to finish in books anyways. And so what I'm trying to say is, so this book, and what they're showing is a basic overlay of I guess what they figured was the most important essential things to know about networking before we start getting into Python networking. And then I'm sure it's going to go over all these in more detail as we go along in the book, or else I don't see the point of this book, or whatnot. But that's the whole beauty of going through books. There's going to be some golden aspects out of it once you get through it and go, oh man, that had some good, golden aspects in it. But it wasn't perfect. There was a lot of wasted time in there too. But if you're teaching yourself and you're just wanting to learn networking, everything, take everything you learn in this video and go do more research into it. So go get an actual networking 101 book, not this Python one, right? And or Google, more about the OSI model and how it connects and stuff. And be creative. The key word there is creative with your searches. So when you're in school, you're going to do a lot of research anyways. You're doing research because research gets your brain going, and you start learning how to learn by doing research, right? So get creative on your research. So the one thing that piqued my interest, right, that it all came back to me, and I was like, oh yeah, I forgot about that, was this network topologies, right? This is very important, because if you're ever setting this up, you need to have a suggestion on how to set this up. Now, there's no pictures of this, and a lot of people learn with pictures better, but you can find pictures of network topologies that better explain this visually. And so what's basically saying is that you have a hub, or not a hub, I'm sorry, that's old. You have a router or a server that is connected to all your other devices on your network, right? But in in some of these, like the bus topology, they're all connected to one server, and if it's connected to the internet, right? And if that server goes out, then everything drops because they're all connected. So that's not a good way to have a huge network, right? And then if you do, you're probably gonna do a hybrid anyways, and you're gonna mix it. But anyways, so star topology is this basically the same thing. It but still has a single point, right? So ring is a ring. They're all connected in a circle. So minimizes data collision, and so data collision too. So I do research on that, okay? And look at pictures of it, because this is very important too. It's all important, right? But the OSI model, man, I struggle with this, but I can remember, and I can remember what it's called, but I got to go slow through it. There's a lot of people that memorize this, and I'm like, all right, tell me about the OSI model. And they're like, okay, it's physical data link network transport session presentation application, and the application is where, and the physical layer is where you start. And then these people could just go through it, but they've invested, like, I would say, majority of their memory space into doing this because they know it's going to get them that job interview, right? But I'm not trying to see this as memorizing the order of it and all that. I want to see it the way they're writing it, what's in each one, and how it works and all that. That's great, especially for hackers or ethical hackers, or people like administrators for troubleshooting and stuff. That's great. I don't want to just memorize the order. That's why I say, please do not throw sausage pizza away. because at least that gets me, not remembering what order they're in and what they are, right? But the ins and outs of it. So this is great right here, I would say, in this book, right? IP addressing, they could have went. They're going into why they're changing it, but they're not going into. They're kind of going in, saying that it's the address of each physical device. But this is kind of lackluster too about that. This the addressing is a little more important too. This is cool information. This is all good information to learn on top of the other things you're gonna learn, right? I would say would be my advice. And, that's their summary. We'll do our own summary. All right, TCP, UDP, socket programming. So this is where it's gonna get great, right? Hopefully, we're gonna be doing some socket, setting up some TCP. What? Key features of TCP. Okay, so yeah, it's just going through some more. And this will be our next video. Socket programming. This is where I want to get basics of sockets. So I want to get to this stuff already and start setting up some sockets in Kali. They give you some commands. And we can even run through this and set up some sockets and see all about sockets and all kinds of stuff, right? Learn some more. So I'm excited to get to here, but you can't. My channel, we don't skip. We don't skip stuff. We don't skip stuff. You can't. I'm a long time martial artist, even though I don't look like it. But and that you can't skip stuff. You got to go step by step. So on our next video, we'll go into chapter 2. And that's TCP and UDP sockets programming. So I hope you learned something. I hope you liked this video. I didn't want to make it too long. That was HackTheFile, and enjoy.